Welcome. Let me start with a statement that sent shockwaves through the developer community. In 2023, Andrej Karpathy, former director of AI at Tesla and a founding member of OpenAI, posted a seemingly casual observation that instantly went viral. He said, and I quote, "The hottest new programming language is English." He followed that up by suggesting that the role of the programmer is shifting from writing code to directing AI. Now, this wasn't some random blogger. This was one of the most respected minds in machine learning. When Karpathy speaks, people listen, and in this case, what they heard made a lot of developers deeply uncomfortable. Headlines across Geek News, Hacker News, and Tech Twitter exploded. Is coding dead? Will AI replace software engineers? Should I even bother learning to code? These weren't abstract philosophical questions anymore. They felt urgent, existential. And that's exactly why we're here today, to cut through the noise and find the real answer. So how did the developer community actually react? The response split almost perfectly along experience lines. Junior developers and bootcamp students felt a wave of panic. Many of them had just invested months, sometimes years, and significant money into learning to code. The idea that AI might render those skills obsolete before they even land their first job was genuinely frightening. On the other side, senior engineers and architects tended to respond with a more measured perspective. They'd seen this movie before. They remembered when visual programming tools in the 90s were going to eliminate programmers. They remembered when Stack Overflow was accused of making developers lazy. They remembered no-code platforms promising to replace engineers entirely. And yet, here they still are. But here's what's different this time, and why we can't simply disconcern the capabilities of AI coding tools. GitHub Copilot, ChatGPT, Cursor, are really impressive in ways that previous automation waves were not. The anxiety is not irrational. It just needs to be properly directed. Before we dive deep, let me give you a roadmap of exactly where this lecture is taking you. We're going to answer 4 fundamental questions over the course of our time together. First, is this threat historically unique, or have developers faced similar disruptions before? Second, what can AI actually do in real production software today, and where does it still completely fall apart? Third, what does the evidence, the hiring data, the salary data, the actual job postings, tell us about how the market is responding? And fourth, and most practically, what specific skills and mindsets should you building right now, not just survive, but thrive in an AI-augmented development world? By the end of this lecture, you will have a concrete, evidence-based answer to replace the vague anxiety with a clear action plan. Let's begin with history, because context is everything. To have a meaningful conversation about whether coding is dead, we first need to be precise about what we're actually talking about. Because coding and software engineering are not the same thing, and conflating them is exactly where most of this debate goes wrong. Coding, in its narrowest sense, is the manual act of typing syntactically correct instructions in a programming language. It's a craft skill, important, learnable, but ultimately an end. Software engineering, on the other hand, is a discipline. It encompasses understanding a problem deeply, decomposing it into solvable components, designing systems that are reliable, maintainable, and scalable, and making judgment calls about trade-offs under uncertainty. Think about it this way. A bricklayer and an architect both work with bricks. If a robot can now lay bricks faster and more accurately than a human, the bricklayer's role changes. But the architect's role doesn't disappear. It actually becomes more valuable. The same abstraction applies here. Writing a for loop is bricklaying. Designing a distributed system that handles 10 million concurrent users is architecture. AI is getting very good at the former. The latter remains deeply human. Now let's put the headline claim directly next to the measurable reality. The claim, in its most extreme form, is this: AI can now write software, therefore developers are obsolete. The reality, as anyone working in production software today can tell you, is considerably more complicated. Yes, AI tools like GitHub Copilot, Cursor, and GPT-4 can generate syntactically correct, often functionally accurate code for well-defined, narrowly scoped tasks. They are genuinely excellent at autocompleting functions, writing unit tests, generating boilerplate, and translating between languages. But the moment you step outside that narrow zone, the picture changes dramatically. AI struggles profoundly with ambiguous requirements, the kind that make up 90% of real client work. It cannot reliably debug subtle concurrency issues, design for non-functional requirements like security or compliance, or understand the organizational and political context that shapes real software decisions. A 2024 study by Princeton and Stanford researchers found that AI-generated code had significantly higher rates of security vulnerabilities than human-written code in complex, multi-file projects. The headline and the reality are not the same story. And that gap is where your career lives. In the previous chapter, we asked the provocative question: Is coding dead? Before we answer that, let's zoom out and look at history, because this is not the first time we've been here. Back in the 1950s, every program was written in raw machine code or assembly language. Writing a single calculation required dozens of handcrafted instructions. Then came Fortran in 1957, the first high-level language. Engineers warned that it would make programmers obsolete. Why hire a specialist if a scientist could write their own formulas directly? Then COBOL arrived in 1959, promising that business managers could write their own data processing logic in plain English-like syntax. Yet the programmer population did not shrink. It exploded. Each new abstraction layer didn't eliminate developers, it moved them up the ladder. The pattern was set. A new tool promises to replace programmers, demand for programmers actually increases, and the cycle repeats. Fast forward to the 1990s and 2000s, and the panic repeated itself, louder and more commercially driven. Tools, Microsoft Access, FileMaker, and Power Builder promised that business analysts could build enterprise applications without a single line of code. Gartner coined the term rapid application development, and analysts predicted that traditional hand coding would become a niche hobby within a decade. Then came the visual programming movement, drag-and-drop interfaces, UML to code generators, and fourth-generation languages designed to auto-generate entire software systems from high-level diagrams. By the early 2000s, platforms like Macromedia Dreamweaver were telling web designers they'd never need to touch HTML again. Yet every single wave failed to eliminate the developer. What happened instead? The tools created new categories of work, integration, customization, performance tuning, security, that demanded even more skilled developers. The no-code tools of today, like Bubble Webflow and Airtable, are the direct spiritual successors of these earlier movements, and they face the same ceiling. So why didn't any of these tools actually eliminate developers? The answer lies in what economists call the productivity paradox, or in tech specifically, the abstraction demand paradox. Every time we add an abstraction layer that makes software easier to build at one level, we simultaneously expand the total surface area of software that society wants to build. When COBOL made business logic easier to express, companies didn't need fewer programmers, they suddenly imagined 10 times more applications they wanted to automate. When visual web builders arrived, millions of new businesses suddenly wanted websites, creating a booming web development industry. This is Jevons paradox applied to software. Making a resource more efficient increases its total consumption. Each new tool lowered the floor, making programming accessible to more people, but dramatically raised the ceiling of what was possible, creating entirely new categories of expert roles. The lesson is clear. Abstraction historically grows the pie. It does not shrink the developer's slice of it. Now, you might be thinking, okay, the sky is falling crowd has been wrong before. But let's be intellectually honest. Something genuinely different is happening with AI code generation, and the data demands we take it seriously. GitHub Copilot launched in 2021, and at that point its ability to complete meaningful functions on standard benchmarks like Humanival was around 8%. By GPT-4 in 2023, that number had risen to 67%. By early 2024, frontier models were solving over 85% of Humanival problems. Some specialized models claim over 90%. To put that in context, Humanival problems represent the kind of algorithmic exercises that junior developers solve in interviews. The velocity of improvement, from 28% to 80% in roughly 2 years, is unlike anything we saw with RADI tools or Forgilovs, which plateaued almost immediately. This is not a linear improvement. It is an exponential one, and we need to be honest about what that means for certain categories of coding work. So if the data shows a genuine capability leap, what actually makes this wave structurally different from COBOL? From visual programming, from RAD tools? The answer is semantic understanding. Every previous automation tool operated on syntax. It could rearrange code templates, generate boilerplate from a schema, or wire up pre-components. But it had zero understanding of what the code was supposed to mean. A UML code generator didn't know what your business problem was. It just mechanically translated boxes and arrows. Large language models are fundamentally different because they operate on meaning. They can read a plain English description of a business problem for context, resolve ambiguity, and produce working code that reflects intent, not just structure. Combined with large context windows, GPT-4's 128KK tokens can hold an entire small codebase in memory. LLMs can reason about architectural relationships across files. This is not a quantitative improvement over past tools, it is a qualitative category shift. And that is exactly what we need to unpack in the next chapter. What does AI actually replace? And where does the human developer become more essential than ever? In the previous chapter, we saw how every major tooling shift, from assemblers to IDEs to Stack Overflow, was once framed as the death of the developer, and yet the profession not only survived but expanded. Now let's get specific. Because unlike those earlier waves, AI tools today are performing real, measurable, production-grade coding tasks. We are not talking about toy demos. GitHub Copilot, Amazon Code Whisperer, and similar tools are already generating boilerplate code, scaffolding entire Kurode endpoints, writing unit tests from function signatures, and auto-completing logic blocks in real codebases. Studies from GitHub show that developers using Copilot complete certain tasks up to 55% faster. If you write a function that reads user data from a database, the AI can instantly suggest the corresponding create, read, update, and delete operations, with error handling included. This is the layer of development that used to occupy a junior developer's first year on the job. AI is now doing it in seconds. Beyond writing code, AI has now entered the code review and documentation pipeline. And this is where it is saving entire engineering teams hours every single day. Traditionally, a pull request would sit in a queue, waiting for a senior engineer to review it. That review might take 30 minutes to an hour, and might not happen until the next morning. Today, tools like CodeRabbit, Sorcery, and integrated AI reviewers can scan a pull request the moment it is opened, flag style violations, detect potential null pointer exceptions, identify security issues like SQL injection risks, and even suggest refactored versions of overly complex functions, all before a human ever looks at it. On the documentation side, tools can now read your function and JS doc or Sphinx-compatible doc strings that are often more complete than what developers write manually. This is not replacing the human reviewer. It is making the human reviewer's job dramatically more focused and effective. So what does this actually mean at the productivity level? Let us look at the numbers. A 2023 GitHub study found that developers using Copilot completed tasks 55% faster on average. A McKinsey analysis estimated that AI assistants could accelerate software development velocity by 20 to 45% across the full software development lifecycle. The concept of the 10x developer, someone who ships dramatically more than their peers, is being redefined. Previously, being a 10 times developer meant raw talent and experience. Today, developer who is skilled at prompting, validating, integrating AI output can effectively multiply their output by that factor regardless of seniority. Think of it like this. AI is a supercharged pair programmer that never gets tired, never gets bored of writing the fifth TRUD service of the day, and never forgets a syntax rule. The developer's job is shifting from being the sole author of every line to being the architect and editor of AI-assisted output. And as we will explore in the next sections, that distinction matters enormously. Now here is where the picture becomes more nuanced, and where the argument that AI will replace developers begins to break down under scrutiny. The most important work in software development is not writing code. It is figuring out what code should be written in the first place. Every real project begins not with a clear specification, but with a fog of ambiguous requirements, conflicting stakeholder expectations, unstated business constraints, and organizational politics. A product manager says we need users to sign up faster. Does that mean simplify the form, add social login, remove email verification? Each of these is a different system, with different security implications, different engineering effort, and different business risk. A senior developer sits in that conversation and helps translate a vague business goal into a precise, implementable specification, while pushing back on ideas that sound, but would create technical debt or compliance problems. No current AI system can walk into a room with a nervous VP, a cautious compliance officer, and an impatient sales lead, read the political dynamics, ask the right clarifying questions, and emerge with a requirements document that everyone will actually agree to. That is irreducibly human work. Let us now look at a concrete comparison that reveals exactly where AI's capabilities hit a wall. On isolated coding tasks, write a function that sorts a list, generate a REST endpoint, fix this syntax error, AI performs extraordinarily well. Benchmarks like Humanival show top models achieving over 85% accuracy on standard coding problems. But shift the problem to system to design. How should we architect a payment processing system that handles 10 million transactions per day, remains consistent during partial network failures, complies with PCI DSS, and can be maintained by a team of 8 engineers over 5 years? And AI falls apart, not because it cannot generate an architecture diagram. It will generate one eagerly. The problem is that it cannot reason about the trade-offs in a way that accounts for your specific team skills, your company's existing infrastructure, your vendor contracts, and your expected growth trajectory. System design is fundamentally about choosing which problems you are willing to live with, given your unique constraints. That requires wisdom accumulated from experience, And that is still very much a human superpower. There is a problem that does not get discussed enough in the excitement around AI coding tools, and it is critically important. AI-generated code is not automatically correct, and it is not automatically safe. In 2021, a Stanford University study tested GitHub Copilot across 89 security-sensitive coding scenarios and found that approximately 40% of the generated code contained security vulnerabilities. These were not edge cases. They included issues like hard-coded credentials, SQL injection openings, and insecure deserialization patterns. AI models hallucinate. They generate code that looks syntactically perfect, passes a casual reading, and yet contains subtle logical errors or dangerous security flaws that only reveal themselves under specific conditions or during a security audit. The problem compounds when junior developers, who are the most eager adopters of these tools, lack the experience to recognize when the AI is confidently wrong. Accepting AI output without verification is not a productivity gain. It is technical debt and security risk shipped at scale. This verification problem leads us directly to one of the most important insights of this entire lecture series. As AI usage in software development, the ability to read, critically evaluate, and correct AI-generated code becomes a premium skill, not a declining one. Think about what this means in practice. If an entire team is using AI to generate 60% of their codebase, someone needs to be able to audit that output with genuine depth. Someone needs to look at a 200-line AI-generated service and say, this logic is correct, but this edge case will fail under concurrent load. And this database query will cause a full table scan at scale. That person is not replaceable by another AI, at least not yet. Senior developers who deeply understand systems, performance characteristics, security patterns, and failure modes are becoming the essential layer between AI output and production systems. This is precisely the shift we will explore in the next chapter, from being a code writer to being a systems thinker. The developers who thrive will not be those who resist AI, nor those who blindly trust it, but those who can verify, direct, and take responsibility for it. In the previous chapter, we drew a clear boundary between what AI is replacing and what it is amplifying. Now, let's ask the harder question. If AI can write code, what exactly is a developer's core value? The answer lies in systems thinking, the ability to hold an entire problem space in your mind, understand how components interact, anticipate second-order consequences, and navigate complexity that no single prompt can fully describe. A code typist executes instructions. A systems thinker architects solutions. Mental models, your internal representations of how technology, users, and business constraints interact, become your most valuable professional asset. Abstraction, the skill of knowing which details to ignore and which to expose, is precisely what separates engineers who can direct AI effectively from those who are simply replaced by it. Let's define precisely what we mean by engineering judgment, because this concept is the irreducible human contribution that AI cannot replicate today. Engineering judgment is the capacity to make well-reasoned decisions under uncertainty with incomplete information, where multiple valid solutions exist and every choice carries trade-offs. Consider a simple scenario. Should your team build a microservices architecture or a monolith? An AI can list pros and cons for both, but only you know your team's size, your deployment maturity, your expected traffic growth, and your organizational politics. Engineering judgment integrates all of that context, technical, human, and business, into a decision you can defend. This is product engineering at its core. Not just building something that works, but building the right thing in the right way for this specific context. That contextual awareness, grounded in experience and situational understanding, is what makes a developer invaluable in an AI-augmented world. There is a persistent cultural myth in software engineering, the brilliant lone hacker, isolated in a dark room, producing genius code through sheer technical mastery. That archetype was always a caricature, but in the AI age it becomes genuinely counterproductive. Compare two developer profiles. The isolated developer writes excellent code, but struggles to explain trade-offs to a product manager, rarely participates in design reviews, and treats stakeholder meetings as interruptions. The collaborative engineer, by contrast, translates technical constraints into business language, co-designs solutions with UX, data, and operations teams, and uses their credibility as a communicator to shape product direction. AI dramatically raises the productive floor for technical output. What it cannot do is represent engineering concerns in a cross-functional meeting, build trust with a nervous client, or negotiate scope with a business stakeholder. Communication and collaboration are now first-class engineering skills, not soft extras, but hard requirements for delivering value. The AI-augmented technology stack has created an entirely new layer of technical roles that barely existed 3 years ago. Let's map this stack from top to bottom. At the application layer, we now have AI product engineers, developers who build user-facing products where LLMs are first-class components, not bolted-on features. Below that sits the orchestration layer, where agent workflow architects design multi-step autonomous pipelines using frameworks like LangChain, LlamaIndex, or AutoGAN. These engineers decide how AI agents chain actions, manage state, and handle failures. Beneath that is the prompt engineering layer, a more nuanced discipline than its name suggests, involving systematic prompt design, evaluation frameworks, and iterative refinement using empirical testing. At the infrastructure layer, LLM pipeline engineers handle embedding pipelines, vector databases, retrieval-augmented generation systems, and API cost optimization. And at the foundation, AI platform engineers manage model serving, fine-tuning workflows, and the underlying compute infrastructure. Each of these roles demands strong software engineering fundamentals. The difference is where you apply them. Now let's walk through what an AI-augmented development workflow actually looks like end-to-end, and identify which human roles anchor each stage. Because understanding where humans remain essential is critical for career planning. The workflow begins with problem definition and scoping, where product engineers and architects translate a business need into a technical specification. No AI can do this step alone, because it requires stakeholder negotiation and contextual understanding. Next comes system design, where senior engineers make architectural decisions, which models to use, how to handle retrieval, where to add guardrails. Then comes AI-assisted implementation, where developers and AI tools collaborate to build features rapidly. This is the stage most affected by AI automation. Following implementation is the evaluation and testing stage, a growing discipline where human engineers design evaluation suites, measure hallucination rates, assess safety properties, and interpret results. This is a high-demand emerging skill. Finally, deployment and monitoring requires MLOps engineers and AI-aware operators who can detect model drift, manage prompt injection risks, and respond to production failures. Humans anchor the beginning, the quality gates, and the operational end of this pipeline. Let's be honest about one of the most uncomfortable implications of the AI transition. It hits junior developers hardest. Traditionally, the junior to senior career ladder was built on repetition. You wrote hundreds of CROD endpoints, debugged countless null pointer exceptions, built dozens of authentication systems, not because these tasks were intellectually deep, but because doing them built intuition, pattern recognition, and the muscle memory of engineering. AI is now automating precisely those practice reps. GitHub Copilot writes your CROD endpoints. ChatGPT debugs your stack traces. That means juniors entering the industry today face a compressed practice environment. They get less exposure to foundational problem solving before being expected to operate at a higher level of abstraction. This creates a genuine skill gap risk. Developers who use AI as a crutch without building underlying mental models may reach mid-career with shallow foundations. The career ladder hasn't disappeared, but the rungs are farther apart, and the climbing requires deliberate, intentional skill building rather than passive accumulation through repetition. Now for the other side of the equation, and it is genuinely exciting. Senior developers with deep architectural judgment are experiencing a level of amplification that was unimaginable 5 years ago. Consider what a senior engineer with strong systems thinking can now accomplish alone. They can scaffold a full-stack application in hours, generate comprehensive tests in minutes, prototype 3 competing architectural approaches simultaneously, and maintain cognitive focus on the highest value design decisions while AI handles implementation detail. This is the 10 times senior effect. Their comparative advantage, accumulated context, architectural vision, the ability to ask the right questions and evaluate AI out critically, is now leveraged across an order of magnitude more output. A senior engineer today effectively commands a team of tireless, fast, but judgment-free AI assistants. The constraint on their productivity is no longer typing speed or boilerplate volume. It is the quality of their thinking. That shift in the constraint function means that investing in depth of understanding, in architectural knowledge, in domain expertise, in engineering judgment has never had a higher return. As we move into the next chapter, we will translate exactly this insight into a concrete learning roadmap. In our last chapter, we explored the fundamental shift from being a code writer to becoming a systems thinker. Now the natural question is, what does that mean in practice? What should you actually be learning right now, today, to stay relevant and thrive? Let's start with the single most important skill that no AI can replace: system design mastery. When you design a distributed system, you are making judgment calls about trade-offs. Consistency versus availability, latency versus throughput, build versus buy. These decisions require understanding business constraints, team capabilities, operational realities, and future growth trajectories. An AI can generate a microservices scaffold in seconds, but it cannot understand that your team of 5 cannot operationally maintain 12 independent services. System design thinking, the ability to reason about scale, failure modes, data flow, and architectural patterns, is the irreplaceable core of what senior engineers do. Double down on it. The second critical skill is AI tool fluency, and I want to be very precise about what that means, because there is a right way and a wrong way to build this skill. The wrong way is tool hopping, trying every new AI assistant as it launches, building demos, posting on social media, but never integrating these tools into a disciplined, repeatable workflow. The right way is what I call disciplined workflow integration. You pick the tools that genuinely accelerate your work. GitHub Copilot for code generation, Claude or GPT-4 for architecture review and documentation, LLM APIs for building intelligent features, and you deeply understand their limitations. You learn prompt engineering not as a party trick but as a professional communication skill. You learn when to trust AI output and, critically, when to verify it. You build personal workflows. How do you use AI during code review, during debugging, during architecture planning? Developers who integrate AI deliberately into every phase of their workflow will produce 2 times more output than those who use it sporadically. The third skill, and this one surprises many developers, is deep domain expertise in a vertical industry. Here is the insight. AI is a generalist. It knows a little about everything. What it fundamentally lacks is the contextual, experiential knowledge comes from years of working inside a specific domain. A developer who has spent 5 years in fintech knows that a transaction processing system cannot simply retry on failure. There are regulatory, financial, and auditability constraints that shape every architectural decision. A healthcare tech developer knows about HIPAA compliance, HL7 data formats, and the clinical workflows that software must support. This domain knowledge is your moat. When you combine deep domain expertise with strong engineering skills and AI fluency, you become extraordinarily hard to replace. AI can generate generic CRUD applications all day. It cannot generate a compliant, contextually appropriate solution for a domain it doesn't truly understand. Your industry knowledge is not secondary to your coding skill, and in the AI age, it may actually become your primary differentiator. Knowing what skills matter in the abstract is useful, but the advice needs to be calibrated to where you are right now in your career. Let's get specific. If you are a junior developer, the AI era creates a genuine tension. AI tools can seemingly shortcut the foundational learning that has historically made developers strong. This is a trap. Data structures, algorithms, computer networking, and operating system fundamentals are not obsolete. They are the conceptual vocabulary you need to evaluate and correct AI-generated code. If you don't understand why a hash map has a 1 average lookup, you cannot reason about why the AI's suggested data structure is wrong for your use case. However, the time you previously spent memorizing syntax, writing boilerplate, and hand-rolling standard utility functions, that time is genuinely freed up. Redirect it toward building more projects, reading system design resources, and learning one cloud platform deeply. The junior roadmap is not about working harder. It's about investing the time AI saves you into the fundamentals that AI cannot teach you. For senior developers, the roadmap looks fundamentally different, and in many ways, the AI era is an enormous opportunity if you respond to it correctly. Your existing engineering depth is an asset. The challenge is leveraging it in new directions. The most important shift for senior engineers is moving from being an individual AI tool user to being the person who defines how your entire team uses AI. This means evaluating AI tooling for team adoption, establishing guardrails around AI-generated code quality, and designing AI-augmented development workflows at the organizational level. Additionally, as AI handles more implementation work, the value of architectural decision-making rises sharply, which means investing in AI-native architecture skills. How do you design systems that incorporate LLM components? How do you manage the non-determinism and latency characteristics of AI services in a production architecture? Senior developers who lead AI adoption at the team level, while deepening their architectural judgment, will find themselves more essential than ever. The leadership vacuum in AI-integrated engineering teams is real, and it's yours to fill. Before we close this chapter, I want to address the failure modes, because knowing what to do is only half the picture. There are 2 opposite but equally dangerous mistakes that developers make when confronted with AI disruption. The first is outright denial, dismissing AI tools as hype, refusing to adopt them, and continuing to work exactly as before. This is career inertia dressed up as principled skepticism. The second failure mode is panic pivoting, abandoning everything you know, chasing AI certifications, frantically rebranding yourself as a prompt engineer, and neglecting the engineering fundamentals that actually make you valuable. Both of these reactions are driven by fear, not strategy. The developers who will struggle are not those who are less intelligent. They are those who respond to uncertainty with either paralysis or panic. The correct response is measured, deliberate, and grounded in a clear-eyed assessment of what is actually changing versus what remains constant in software engineering. So what does the right approach actually look like in practice? I want to leave you with a concrete three-step framework for deliberate skill building that treats AI as a learning accelerator rather than a crutch. Step 1. Build something real with AI every week. Not a tutorial project, a real tool that solves a problem you or someone you know actually has. AI will help you build it faster, but the architectural decisions remain yours. Step 2. After AI helps you generate code, always read and understand it. Treat AI output like a junior developer's pull request. Review it, question it, improve it. This keeps your judgment sharp while you benefit from the speed. Step 3. Invest 20% of your reclaimed time into the fundamentals that AI cannot help you learn. System design practice, reading architecture case studies, contributing to open source. As we head into our final chapter, remember, the goal is not to compete with AI. The goal is to become the developer who knows how to direct it, evaluate it, and build with it in ways that create real value. That developer has an extraordinary future ahead. So let's answer the question we opened with. Is coding dead in the AI age? The honest answer is nuanced. Writing boilerplate code, the kind that fills lines without requiring deep thought. Yes, that skill is rapidly becoming a commodity. AI can generate it faster and more reliably than most humans. But software engineering as a discipline, it has never been more valuable. The ability to reason about systems, to ask the right questions, to validate AI output, to make architectural trade-offs, these are human judgments that AI cannot replace. Think of it this way. Calculators didn't kill mathematicians. They freed mathematicians to solve harder problems. AI is doing the same for developers. The developers who thrive are not those who resist this shift, but those who understand it clearly and position themselves on the right side of it. This brings us to a fundamental reframe of developer identity. For decades, the developer's badge of honor was craft, elegant code, clever algorithms, clean syntax written by hand. That identity served us well. But in the AI age, clinging to that identity is a liability. The developer who thrives is not a code craftsman protecting their handwritten art. They are a systems architect, someone who defines problems with precision, orchestrates AI tools with intent, validates outputs with rigor, and takes full responsibility for outcomes. This is not a downgrade. It is an upgrade. You are no longer limited by how fast you can type or how much syntax you can memorize. You are empowered by how clearly you can think. As the computer scientist Edsger Dijkstra once said, the question of whether computers can think is like the question of whether submarines can swim. AI does not think like engineers. Engineers who understand that distinction will always have the edge. Before we close, let's consolidate everything across this lecture into 5 core insights you can carry forward and reference immediately. First, AI is a force multiplier, not a replacement. It amplifies the engineer who already thinks clearly. Second, the skills that matter most are now problem decomposition, system design, and critical evaluation of AI output. Prompt engineering is a real, learnable discipline. How you communicate with AI tools directly determines the quality of what you get back. Fourth, T-shaped expertise, one deep domain plus broad AI fluency, is the career profile most resilient to automation. And fifth, the roadmap is not about learning everything at once. It is about strategic, incremental investment in the skills that compound over time. Screenshot this slide. These 5 points are your compass for every learning decision you make in the next year. Now let's turn insight into momentum with 3 specific actions to take this week. Not someday, this week. Action 1, learn. Pick one AI coding tool you have not used seriously yet. GitHub Copilot, Cursor, or Claude, and spend 2 focused hours prompting it to build something real. Study what it gets right and what it gets wrong. That gap is your curriculum. Action 2, build. Take a project you have been postponing and use AI assistance to ship a working prototype in under 5 hours. Document every prompt you write. Review what made a prompt effective versus vague. Action 3, discuss. Find one developer community online, a Discord, a forum, a LinkedIn group, and post a question or insight from this lecture. Teaching and debating accelerates learning faster than passive consumption. These 3 steps activate the learn, build, dis loop that defines every developer who stays ahead. Thank you for watching, and I'll see you in the next series where we go deep on AI native software architecture.